This is homework number 8, problem number 3. Here we want to determine the moment of inertia, Ix and Iy, of the area shown about the vertical and horizontal axis that running through the centroid of the area. And we have W equals 2 inches. So for the first step to solve this question will be finding the centroid of this area. So we can see that this shape is combined by two rectangular shapes. So we can just cut it and make it two sections. So let's say this is number 1 and this is number 2. And we can set it up a table to find the centroid in both x and y. However, in this problem, the centroid of x component will be super easy just by inspection. This is 9, so the centroid will be just half, or somewhere half in the middle, which is 4.5. However, in y, we need to find it out ourselves. So let's set up the table here, and the first step will be finding the area of number 1, which is just 2 times 9, which is equals to 18. And the centroid of number 1 itself will be just 1, if we say this is 0. So just this 1, and by multiplying these two numbers together, we got 18. And for area number 2, we have 6 inch times 3 inch, which is also 18. And the y value of centroid would be 2 here plus 3, which gives us 5. And by multiplying these two together, we got 90. And summing up these two numbers, we got 36 and 108. And now we can plug into the centroid equation here, which is 108 over 36. We got the y value of centroid would be 3 inches. So let's draw this again. The centroid would be somewhere here, which is 4.5 and 3. And let's draw two lines. That will be our axis to calculate the moment of inertia. So x here and y here. Or let's say x and y for now. And then we can move on to the next step, which is finding the moment of inertia still separately for 1 and 2. And we can apply the equation here that Ix would be the centroid of the shape itself plus area times dy squared, which means if we say our moment of inertia of x of this shape is here, and we can just plug in that number into the equation and we can find the moment of inertia about x-axis here. So we can just using this formula in the given here, we have Ix equals 1 over 12 bh cubed. Here we have our b equals 9 and h equals 2. And that will we can just plug into the equation here. So our Ix would be let's take it down here, 9 plus 2 cubed plus the area would be 18, and the distance from the centroid of number 1 to the centroid in general would be 3 minus 1, so which is 2 here. I'll just keep in 3 for now. And by summing these, we have 78 inches to the 4th power. And let's do the same thing for number 2. So that's number 1. For number 2, we have 1 over 12. And so here we have our B for is 3 inch and H is 6 inches. The area is also 18. And the distance here would be, that's 2 plus 3. We have 5 minus 3, so it's 2. And we got 126 inches to the 4th power. And now the Ix in general will be just Ix1 plus Ix2, which gives us 204 inches to the 4th. We're not done yet. We still need to find the moment of inertia about the y axis. So we do the same thing here. We still do it one by one. Iy 1 equals 1 over 12. So using the equation here, b is 9 cube times 2. And since we are already so the centroid in y axis for area number 1 only would be the same with the centroid, y centroid of the general shape. So there's no like extra distance between them. So we can just add 0 or just ignore it. And for y2, it's doing the same thing. We have 3 cubed times 6. And by adding these two up, we have Iy equals 135, or 135 inches to the 4th. And that will be our final answer.